All right, so we are finishing chapter 7, commonly missed questions, and this is number 8. In number 8, we see that we have a 90-degree angle here with a 90-degree angle there. We are also told that we have congruent angle here and a congruent angle here. And so therefore, that is enough information for us to say that this is angle-angle similarity. And if we look at how to name our similarity statement, if we start with U, which is the 90-degree angle, and go to W, which is the green dot, and then over to Z, which is how they have it named here, that means we must follow the same procedure. So we're going to go from the 90-degree angle U to the green dot, which is Y, and then to the W. So let me go ahead and write that in there, that we are going to be similar to triangle U, Y, W. And I'm going to write that down here as well, triangle U, Y, W. And now we can either look at our triangle to do similarities or our similarity ratios, or we can look at the naming of the similarity statement. So if I'm looking at UY, then it's going to be proportional to UZ. Excuse me, UW. If, let me fill this back in here again here. If we have WU, sorry about that. If we have WU, let me erase that. If we have WU, and that's going to be ZU. And then if we have WY, then that would be ZW. So there are our ratios, and wants us to be able to find these sides. If we look at what's up here though, if we look at this triangle right here, then what we should be able to do is to use the Pythagorean theorem, so that, you know, we have the hypotenuse squared, and that's equal to 32 squared, and then what we're looking for. And so what we would find out is that y would equal 24, which would be this side right here. And so we're looking at the three things that we're trying to find. One of those is WU, and we just found that is 24. Okay, if we look at what else is left to find, and we're going to set up a proportion to do that, then we're going to have WU and we're looking for now WZ and ZU, which both have x's in them. So we need to find the x, and once we find the x, we can find the other one. So if I look at setting up a proportion here, I could take and say that we have 24 to 32, and then 24 and x plus 6. So I can use that proportion to help set this up. And so that would give me 24 over 32 and x plus 6 over 24. And when I solve that, cross multiply and set up that equation, that's going to give me x equals 12. So that means that when I look at WZ, that is 3 times 12, 36, minus 6, that's going to give me a 30. And x plus 6, 12 plus 6, that's going to give me an 18. If we look at the next one over here, number 9, we are told that, excuse me, angle GHJ right here is congruent to angle HDG, which is this angle here. And so then if we know that we have this angle to this angle, and as well this angle to this angle, then I'm going to say that this is going to be by angle-angle similarity. And so when it tells us that we have angle D, triangle DGH, DGH, that is going to be similar to triangle HGD. Sorry, HGG. Oh my goodness, HGJ. I can't get that out right. Okay, so then looking at this, if I have DG, then I know that that's going to match up with HG. If I have HD, that's going to match up with JH proportionally. And then HG would be GJG. It's hard having those two letters in the same one here. Okay, and if we look at proportions here, we can take and say that this side here, which is 7, and this side here, which is x minus 2, so I'm going to have 7 over 2x minus 2, and that is going to equal this side over here, which is going to be 10, and then 2x plus 4. And we can cross multiply and divide, and we're going to get x is equal to 8. Once we find out that x is equal to 8, then we can say that dg, which is 2x minus 2, that's 2 times 8, which is 16. 16 minus 2 is going to give us a 14. And then HD, which is 2x plus 4, so 2 times 8 is 16. 16 plus 4 is 20. All right, number 10, solve for each variable in alphabetical order. Do not use decimals in your work. Okay, so if I look at this, the first thing I notice is that I have a Pythagorean, or have a right triangle, and if I look at my sides here, if I see that this is 3, then this is 4, then this must be a 5 using Pythagorean triples. So that is going to give me that x is 5. And then I'm going to have to use that to set up some proportions. And so I'm going to start by saying that if I look at this side over here, I'm going to have 3 to y, and then I will have 5 to this part right here, which if this is 4 and this is y, then this part must be 4 minus y. And I'm going to cross multiply. I'll get 8y equals 12, and then y will equal 3 over 2. So we have found x, we have found y, and we now need to find z. And so if we look at that, we are going to have that is a right triangle also, and we now know the value of y. So what I could say is that I'm going to have 3 squared plus 3 halves squared, and that's going to give me what's missing there, z squared, and I want to find z. So I'm going to have 9 plus 9 fourths equals z squared. And so that is going to give me 436, 45 fourths equals z squared. And if I square root both sides, I'm going to have z is equal to, let's see, that is going to give me square root of 4 is 2. The square root of 45, 9 times 5 is going to be 3 radical 5. And so now I know what z is. So I found x and y and z.